Welcome to part 2 of Crypto Convos with guest Rohit Sethi, CEO of Security Compass. Part 1 discussed the challenges of modern software development and the trend to shift left via developer-centric threat modeling. Part 2 will explore developer history with cryptography and how the quantum era will require merging cryptographic upkeep with DevSecOps. Enjoy.
So let's shift. So this is, after all, I'd like to talk about cryptography a little bit, and I feel like I just ran into a customer the other day that would have been perfect for you to have a conversation with. Because the conversation went something like this, right? The problem with cryptography is that it seems to be evolving as well, right? And we could talk about this. We could talk about post-quantum cryptography. We could talk about modern day cryptography, because if you look at sort of TLS, the first version of TLS was a great innovation, right? Like no longer SSL. Now we're doing TLS. Now there's TLS 1.3, right? Like there's been absolute evolving there as well. And I'm talking to this customer, and he's talking about this. He says, listen, right? The hard problem is that we've containerized everything. We've done a really good job of the whole microservices architecture. My product is all right, but now I've got containers kicking around that have cryptographic modules in it that are half a decade old, and nobody kind of knows about it. Nobody's paying attention to it. Like, I don't have the processes to discover it. What do I even do with that? It seems like that's right in your wheelhouse.
Yeah, for sure. I would say that, when you think about, it's funny, if I think about cryptography and the way I used to talk about it a decade ago, right? When we did developer training, mostly we were just teaching people not to roll your own crypto. Don't write your own. Don't try to interpret AES or RSA or whatever the algorithm was at the time, and try to implement it yourself. There's all kinds of challenges with it. Most people didn't really understand cryptography in general. Now the word crypto is kind of like just in the general public sense, people understand it, obviously from things like cryptocurrency. But when you look at software development, I think there's generally more awareness that, whether it's encryption or hashing or, whatever function you need, it's part of modern computing. It's part of modern software development. We tend to think of a few different places like where we'll see people use cryptography, and I'll get to sort of some of the challenges you're talking about, right? But obviously there's like encryption at rest, encryption in transit. There's things like hashing, hashing passwords and these sorts of things. What has changed, I think, from my lens, is that once upon a time, people would have to, for example, write authentication code themselves. So they'd write the code that when somebody logs in, what do you do about it, right? Now you see that less and less, right? There are single sign-on providers, identity management providers that kind of abstract that challenge for you, so you're not doing it yourself, right? So I think there's the idea that a lot of the day-to-day use of crypto for the modern software developer has been abstracted out to like some kind of service provider in some way, shape, or form. However, right, and to your point, there's still implementations of various algorithms lying around, right? And so you might still find people that are encrypting data at rest themselves, as opposed to using some third-party service or operating system service or whatever to make that happen. And this kind of gets to the challenge of the world I live in, kind of security by design, right? Because you have all these different containers and you aggregate them, or services, right, resting on containers, and aggregate them to make an application. The first thing you have to understand is like, well, what is your inventory of applications? So you have a billing system, right? And there's some custom code there that sits on top of everything, but maybe it relies on 40 different microservices that have been written by different engineers with different data stores in the background. So you have to have an understanding. First of all, you have to inventory, right? And this is classically true for every area of security. You have to understand what your inventory is.
What's there, right? Yeah.
What do you have, right? And you have to be able to catalog that, and you have to be able to keep it up to date. If you can't do that, then you have rogue, shadow IT, essentially, right? The same sort of challenge you have. You have code kind of running somewhere that a centralized group of people who focus on things like security, right, just can't know about, right? So you have to get your hands around understanding the sprawl of application development. And this is where things like threat modeling are really interesting, because one of the core parts of threat modeling is to understand the system that you're building. And so, a lot of times people will generate diagrams, or they will, use sort of like metadata to describe a system, and that's sort of the basis of the architecture. But understanding what components make a system and then tracking it is really important. So for example, if you were building, let's just say for argument's sake, you decided you were going to write your own authentication, but you want to log in users. Not that you should, but let's just say you did. So understanding all the pieces that go into that authentication system, right? And then, understanding that there's a piece there that isn't implementing, say what, like hashing, for example, right? And keeping track of that. And then so what we need to do is just understand that over time, as cryptography evolves, and we're reliant on algorithms that maybe were implemented a number of years ago, and people find ways to break them, or quantum computing comes to play, it becomes a reality, or mainstream reality. That you have to know where that thing is, and then you have to be able to tell the developer what they need to do about it, right? So first, like cataloging all of the systems and understanding where these pieces fit, and you do that before you need it, right? So that's kind of like the fundamental challenge. And then the second is a distribution mechanism to say, okay, of all the applications or products that I have in our portfolio, how many are going to be impacted by this latest change by NIST, right? And you can do that if you have a good inventory, and you're able to tie to say these kinds of systems, right, need to do the following set of procedures to upgrade, right? And then you can really dive in and start to work with the individual teams if they're facing challenges. But ultimately, that's where we see our customers start tackling this problem from a design or architecture standpoint, as opposed to the alternative, which we see a lot of companies have done historically, is kind of test for it. Let's go out there and discover where we might have code running somewhere, and it's implemented its own, rolled their own crypto or whatever. It's really difficult to do that, right? Like but it's often the default way people think about it. So this is a problem you got to get ahead of. You have to kind of implement it as part of your core software development, software acquisition process, so that as new systems come on board, you're constantly tracking them, and you always know, where to go, which systems you need to go to when, there is a particular issue that people need to work on.
Yeah, it was the inventory is no good if it's like not up to date, and
that's right.
And process around that, right? Like, and a lot of people still think about software in that way, right? Like, it's not part of a process; it's part of a widget you've constructed. So let me one area that I really want to dig into, and we've been talking for a while now, and I'm really enjoying this, but I want to hit on this topic, because one thing that you and your company and people that are embracing DevOps and CI/CD are very much in love with is the agility that the process offers. It's like, okay, well, that's great, right? Like, we have a term in the cryptography space, I deal with it all the time, which is called crypto agility. Now, where this comes from is the following, right? We have seen some changes over the years to cryptography. We have, not just the quantum threat. Like, if we think about, for instance, what we saw, you talked about Java. Well, Java 15 had a bit of a bug, right, with the certificate validation error, right? Like, basically, I could be anyone I wanted to be as long as I did a good proper mem set on the certificate that I was offering, right? So cryptography has bugs. Cryptography has issues. Libraries that you depend upon from others have bugs. And now we have these post-quantum cryptographic algorithms, which are based on fairly new mathematical techniques. Net result is that some of them break, some of them get updated, and need to get updated again, right? And so, so we accept that. We accept the fact that there are problems with cryptography, and that we need to sort of stay on top of it, just like we might have updates to our databases or other libraries, etc. So agility is the answer, but I don't think agility is enough, right? And this is where I'm toss you a bit of a controversial position on this. See sort of what you do with it. It is not enough, and the reason it's not enough is that if I am able to break your cryptography, I am not going to tell you about it, right? What I'm going to do is I'm going to keep on reading your data, right? It's not like ransomware, right? Like if I hack into your computer, I encrypt your computer, I'm going to come after you. It's like I want my Bitcoin, right? To give you the key. When it comes to espionage, right? Espionage is a silent killer, and therefore, and I want to see how you saw that, right? Because obviously in an agile way, can I deal with updates to cryptography, whether it be the libraries or even the algorithms themselves. But what do I do with the fact that something may not be trustworthy and I'm depending on it? And what I typically say is that, listen, the solution here is diversification, right? You diversify your cryptography to a point where you no longer have a single point of failure. How does that, first of all, do you agree with me? Do you think it's ridiculous, or do you do you see that fitting sort of in the ecosystem that you operate in? What do you think?
Yeah, it's a really interesting question, because it kind of, I'll say it's like a part of a class of problems, right? That as you dig into any area of security, I think you find that there's kind of the current state of best practice, and then there's all kinds of ways that current state of best practice is maybe not adequate enough for a certain kind of threat, right? And there's really no exception there. Like any area of security, you're going to find this. Certainly true in application security in the world I live in. It's obviously true in cryptography as well. I think that, you're right. Like the idea of agility and just being able to replace libraries and these sorts of things is not sufficient. And I think if you kind of step up and think about a general way of approaching cybersecurity, you have these concepts of things like defense in depth, right? So you should never rely on a single control to be the difference between a breach and a non-breach, right? There should really be a number of ways that systems are protected. Now, what I'd offer is, from my experience, there certainly have been breaches related specifically to breaking cryptographic algorithms. Mostly, they're in the implementation of the algorithm as opposed to the math, right? And then those are things that are relatively easy to fix. If I think about, though, where I see most of the breaches, right, the incidents that come out, they're just a lot more simple than that, right? And so I think what you're talking about, Vince, is a state of maturity that a lot of organizations are nowhere near, right? If you think about, for example, some of the massive breaches that have happened over the past couple of years, you go back to like the Log4j vulnerability, right? Which, is a vulnerability inside the Log4j, and it was an interpretation of, parameters that could have easily been escaped. This is the kind of vulnerability that we've known about for many, many, many years.
Exactly.
Right? And you'll find that there's so many of these things that result in breaches, a vulnerability that we've known about for many, many years, but the people who are writing the code, right, don't know how to apply them. So we're still at a state where things that we have, best practices that we've known about for decades, cannot be applied in a consistent way, right? That I think it makes it hard for people to focus on, like, well, what if my crypto algorithm fails, right? What am I going to do about it? Now, I agree with you, by the way, diversity in terms of not hinging on a single thing. Again, single point of failure is obviously, a great way to go. I think, unfortunately, there's a level of complexity and cost that most organizations aren't willing to bear just yet. I think you'll probably find there are some banks and some really large tech companies and maybe defense organizations that are ready to think that way, but most companies are nowhere near that, right? So unfortunately, I think we're a number of years away before they even contemplate this problem.
No, and I think it's, it goes hand in hand with the point that you made earlier, right? Like, which is like, listen, right, the adoption of proper DevOps and bringing security into DevOps, like that already, right? Like that already is a big bridge to cross for many, right? Like the starting to think, and not to mention the fact, right? Like most large organizations, right, have software applications that were built in-house that the entire business depends upon. Like think about like think about an airline booking system. You don't buy those off the shelf, right? Like think about rental cars, think about inventory, right? Like a lot of these things are extensions of existing applications, a lot of which right aren't microservices based or are not yet. Like so you're right. But
there's actually
your point well taken. Yeah.
There's a second class of challenge there that reminded me of that I wanted to bring to light, right? Yeah. Which is one thing we're seeing is an emergence of a secondary discipline, product security, which is most cybersecurity standards, laws, et cetera, are focused on the enterprise, right? So if you are a software vendor today, and you go to try to sell to a client that's security sensitive, they'll probably ask you for a SOC 2 Type 2 report or ISO 27001 designation. Those two standards, right, are generally like enterprise security standards, right? So they're really about how are you thinking about security everywhere, and that's important to know. How secure are your vendors? However, when you're buying a software product, you should also know how secure that software product is, right? And it's interesting because these standards are not necessarily focused on how secure the product is or the process of creating the product. And it's interesting because it kind of is a parallel to what we see between the chief information security officer and the chief product security officer. The chief information security officer is focused on the enterprise security posture, right? And so what I often see is like we'll talk about things like DevSecOps, but the CISO is really focused on phishing of the employees because they just failed a phishing test last week, or there was an incident and it was related to phishing or ransomware or these sorts of things, right? So part of the challenge we have is a kind of a fundamental misalignment where we're building and selling software, and it's its own area of expertise. The chief technology officer, chief information officer, most of these companies that were head of engineering doesn't own security. They see security as the responsibility of a different group, and that other group, application or software or product security, is not their primary responsibility. And so it's kind of a little bit lower on the food chain for all the other things that they need to be doing. And so therefore they're producing products that all the rest of us use that are vulnerable, that we probably could have, avoided a number of issues. So even, and that includes some of the things you're talking about from a crypto perspective, right? Like making sure that we are designing them in such a way that we do have true crypto agility, for example, right? Or we're getting ahead of particular issues. Those things don't fit on the set of top responsibilities for either of those groups. However, what we have started to see is the emergence of this product security function, where it absolutely is a top priority for that group. They see themselves as aligned to revenue. The product that we're selling needs to be secure and more secure than the competition. And so we need to get ahead of these kinds of problems, right? So that's a thing that I think is an interesting trend to track, and I think will make a difference in terms of security by design and
and I would love to help you push that point along. I mean, I've done this, right? I've done the design of the secure software engineering practices, and then right the head of product management is like, well, the customer is asking for feature X, it's not asking for security, right? And the CISO is indeed worried about like, well, I'm trying to get this single sign-on project working, right? Like you don't find a good home for it, and the responsibility lies entirely with the complete business, because the product is the information you collect, right? Like it needs to become part of that fabric. So I certainly want to beat that drum with you. So listen, we've been talking for a long time, and I think we could keep going for another hour if we wanted to. I completely agree with, and I really appreciate the points that you shared today. So let me say thank you, Rohit, for being here with me today and doing this this crypto convo.
Appreciate it. Thank you so much, Vince. Appreciate the opportunity.
Yeah, it was good. And thanks also for all of our listeners, viewers, wherever you are, and hoping to see you again next time at the next Crypto Convos. Thank you so much.
Thank you.